Hello dear students. In our earlier video we have seen about the binary language or binary number system. All digital machines, we know that all these machines like computers, mobiles, laptops, all these machines use binary language. So it's important to learn about the binary number system, which this part we have covered in our earlier lecture. But apart from this binary number system, there are other number systems also which are important to learn, like octal number system, hexadecimal number system. So in this video we are going to learn about octal number system. Basically in octal number systems we'll see the base, the need of the octal number system, and the conversion of octal number system with binary number system. Okay, so we'll start with the base. Base is very important for any number system. We know that every number system has certain symbols to be used. Like for decimal, the symbols are 0 to 9. So that's why the total number of symbols any number system uses is known as base. In octal number system, the symbols used are 0 to 7. The total number of symbols used are 8. And hence the base of this octal number system is 8. Okay, we can represent, there is a particular way of representing any number system. We generally write that a particular number in the bracket and the base of that number system here. So octal number system can be represented this way. Binary number system can be represented this way. Decimal this way. As we know that octal number system uses the numbers 0 to 7. So any other number like 8 and 9, these numbers are not there in the octal number system. For example, 1 to 7, this can be a octal number, but 1, 3, 9, this can't be an octal number because 9 is there. 9 is not any symbol in octal number. 1, 4, 8, this again can't be any octal number because 8 is also not there in octal number system. Only 0 to 7 symbols are used, and that's why the base is 8. Okay, now what is the need of this number system? Because we know all the digital machines communicate in binary language, so we need to learn binary number system. What is the need of octal number system is, now in a binary number system we know we have the string. We represent binary number this way. Any number, if the number is bigger, so the string will be large, 1 0 1 1 0 1, like this. Sometimes the string becomes very large. String means 1 and zeros. So here the possibility is, the firstly, the writing the number of ones and zeros is tedious if the string is large. So that is a tedious part. Secondly, there is a chances of error while writing the string, because if I am writing this way, sometimes instead of 0 if I write 1, the total meaning changes. Okay, so there is this number system when we deal with, because the number system should be human friendly also. This number system, binary number system, is made for the computer, digital machine, so it is computer friendly, machine friendly. But for the human, just dealing with ones and zeros is very difficult, or we can commit some errors there, and that's why we have the other number system, that is octal number system, which has the symbols which are familiar to us, 0 to 7. So this number system becomes compact. If we want to convert this long string into the octal number, we'll get small numbers or the compact digit. So the first advantage of using octal number is it is giving us compact nature. So our job does not become tedious. Secondly, the error also becomes less while writing the octal number system. Okay, so these two reasons are there, and the third reason is conversion of octal number into binary or binary to octal conversion is again very easy. So because of these three reasons, we have the octal number system, or octal number system comes in the picture. Okay. Now the last part of this video is the conversion of this number system with binary number system. We'll see the conversion of octal number system. If I write the octal number, so we know that 0, 1, 2, 3, 4, 5, 6, 7. These are the octal number. And how can we convert this octal number into binary? Very simple step. Okay. Firstly, we should understand, we should compare the octal number system with the binary. For example, the binary number system has base 2. Octal number system has base 8. So 2 raised to 3 is 8. So that's why the octal number system needs 3 bits to be represented. For example, binary octal number 0 can be represented in binary with 3 zeros. Octal number 1, 0, 0, 1. How I am getting this is, you have to just convert this octal number into binary with the help of the same way which we have done for the while converting the decimal number into binary. For example, this is the octal number. So what I will do is 2 ones are 2, remainder 0. 1 cannot be divided by 2. So I'll write 1. I'll shift 1 here, and then I'm going bottom to top. So what I'm getting, 1, 0. But as we know that octal number, when we represent that in binary, we have to take help of 3 bits. So there is nothing here, so I can write 0. Okay. 3. If I want to convert octal 3 in binary, what I will do, I'll follow the same step. 3. So 2 ones are 2. Then remainder is 1. 1 is quotient now. 1 cannot get divided by 2. So I'll shift it here. Bottom to top. So 1, 1. There is nothing to represent. So write 0. 4. I can write this way. The same method which we follow while converting any decimal number into binary. 2 2s are 4, remainder 0. 2 1s are 2, remainder 0. And then 1 cannot be divided by 2. So I will shift it here, bottom to top. Okay. So it will be 1 can be represented by 4 can be represented as 1 0 0. So with practice actually you can do this. Now 5 can be represented this way, 6 can be represented this way, 7 1 1 1. There is another also method, like we know that this bit, this has the weight 2 raised to 0, 2 raised to 1, 2 raised to 2. So this is 1, this is 2, this is 4. So for example, this bit 0 0, so only 2 raised to 2, that is 4. This is 2 raised to 0 means 1, 0, and this 4 plus 1, that is 5. This is also the way. But for sometimes what happen, initially it becomes difficult for the student to directly have this particular thing. So I generally ask students to go this way. And as the number of symbols are only 7 in octal number system, these 7 bits are sufficient to know. Any other bits, for example, now if I have the number 2, 4, 6, this is the octal number, right? If I have to convert this number into binary, what I will do is, I will take every number separately. I will take every digit of octal number system separately, and I will represent that in 3 bits. Like for example 6 can be represented by 1 1 0. 4 can be represented by 100 and 2 can be represented by 010. So this is the string which this is the binary equivalent of this octal number. Okay, so any number can be converted this way. 738. Is this an octal number? No, because 8 is not there in the octal number system. So this is not octal number. I'll take any number 6. So again the same thing we have to take. I am taking other example. Okay, so 6 can be represented as 110. 3 can be represented as 011. 7 can be represented as 111. So this is the binary equivalent for this octal number. Octal to binary or even binary to octal, these conversions are quite simple. That's why we are using octal number system. So this way we can convert any octal number into binary. Now last part of this video is conversion of any binary number into octal. Okay, again this process is very simple. Take any binary number. Okay, this is binary number. If I want to convert this number into octal, so what I have to do is simple steps. I am writing this number as it is. Then this number have the group of 3 beats. 1 1 1, 1 beat, 1 1 1, 0 1 1. This is the second group. And write the decimal equivalent. You can say like 111 is 7, 110 is 6. Okay, so 67 is the octal equivalent for this string. Okay, I'll take the other example. I'll take a bit longer string. Okay, okay. Now same thing, I'm having this string. I will divide that string into group of 3. 1 1 1, 1 2 3, 1 2 3. Now what happen is only here the 1 remain. So I can add 2 beats, 2 zeros there in order to make it group of 3. Okay, so 0 1 1 is 3, 0 1 1 is again 3, 1 0 1 is 5, 0 0 1 is 1. So this is the octal equivalent for this binary string. Okay, so in order to convert any binary string into octal, we have to write that string and then have the group of 3. You part that string into group of 3 bits and then write the equivalent octal code for that. I hope the octal number system is clear to you. We have seen the base of the octal number system. We have seen the need of the octal number system, and finally we have learned the conversion of octal number into binary and binary to octal.